All right, remember special triangles from geometry? Good, I like the enthusiasm. We're going to get rolling on this. So here we go. We are going to review special triangles because we're going to use them a whole bunch in the unit circle next week. All right, giddy up. First one we'll start with is the 45, 45, 90. This is an isosceles right triangle. If you have, oh, Jada's already starting to yawn. Oh man, all right. We got to hurry up here. If you have a 45, 45, 90 right triangle, that means that it's isosceles, and the only two numbers that add up to 90 that are the same number are 45, 45. So that means that these two sides of the triangle are the same. Let's just call them x. And so what would the hypotenuse be if each leg was x? So if we did the Pythagorean theorem, Pythagorean theorem, as Natalie likes to call it, we would do x squared plus x squared equals h squared. And then x squared plus x squared is 2x squared. So 2x squared equals h squared. And then h is equal to the square root of 2x squared. But that simplifies to root 2 times root x squared. Gosh, I'm getting long with this. So root x squared is just x. So what is this? X root 2. So all that just to say that and show you, if we use a Pythagorean theorem, that the hypotenuse is always root 2 times the leg. So in any 45, 45, 90, you take whatever the leg is and multiply it by root 2 to get the hypotenuse. Okay? So if I want to go from the leg to the hypotenuse, I multiply by root 2. What if I want to go backwards? What if I want to go from the hypotenuse to the leg? I don't times by root 2, I divide by root 2. And so we end up having to have some rationalizing the denominator and stuff going on. So in this first example down here, I'm given one of the legs. And oh, by the way, there's like 3 ways to know if it's a 45, 45, 90. In this case, you know it's a 45, 45, 90 because of these congruent angle marks. There's only 2 angles that add up to 90, 2 numbers that add up to 90 that are the same number. They're 45, 45. Same thing here. If these 2 lines are congruent and these 2 sides are congruent, then the angles have to be congruent, and therefore this is a 45, 45, 90. So all of these are 45, 45, 90s. They just all say they are in different ways. That one just explicitly says 45, 45, 90. So how do I go from the leg to the hypotenuse in a 45, 45, 90? I times by root 2. So what is 4 root 3 times root 2? 4 root 6, not 4 root 5. You got to multiply them. So 4 root 6. Good. And then the other one, since it is isosceles, is also 4 root 3. Mr. Dahl, coming to you live. I'm recording. What's up? No, you have a little joke for us or anything for the video? This would be good. Dahl cameo. Quick little joke.
Hi. Why does the ocean roar? Why? You'd roar too if you had crabs under you.
That's a good one. All right. Good. Crab's joke. All right. Crab joke. Crab joke. So how do we go backwards? We go backwards by dividing, so we got to divide by root 2. Divide by square root 2. So this is where you get a little bit tricky, but you have 3 root 6 divided by root 2. And the easiest way to do that, you don't have to rationalize this one. You can just that root 2 and that root 6 you can factor a root 2 out, so this just becomes a root 3. Okay, so now each leg is 3 root 3. So that just saves you a whole bunch of work doing it that way rather than rationalizing it, multiply by root 2 over root 2. So anyway, 3 root 3, and then the other one is also the same. The other one is also 3 root 3. Okay. And then over here, if we have just a regular plain old 6, then the other one is just a regular plain old 6. And the hypotenuse then would be 6 root 2. So that was the easiest one. Okay, so that's the 45, 45, 90. Questions that I've been asked. Are we going to be given these formulas? No, you got to know the relationship. All right, so we're going to use this stuff a whole bunch in unit circle. The next one is the 30, 60, 90. This is the best, most friendliest little special right triangle there is. The reason because the cosine of 60 degrees is a half, and the sine of 30 degrees is a half. It's exactly 0.5. It's the nicest, neatest value in the cosine or sine value there is. The yawns are just ripping through this class right now. You guys are faking it or what? Holy cow. All right, so the short leg, let's say the short leg, which is opposite the 30, is x. Then the hypotenuse is, do you remember this? 2x, it's double. And the root 3, the long leg is x root 3. So you might remember that from geometry, hopefully. So now if you want to go to the long leg from the short leg, you times it by 2, eh? If you want to go from the short leg to the long leg, I think I said long leg, I meant hypotenuse. If you want to go short leg to the long leg, you times by root 3. If you want to go backwards, you just divide. So if I go backwards, I divide by root 3. If I go, oh, you guys are annoying. If I go backwards from the hypotenuse, you divide by 2. Their coping mechanism for falling asleep is fake yawning and then laughing collectively. Good job. Way to be a team, you guys. Mm-hmm. Yeah. All right. Let's do some examples here. Let's say we have the long leg. I was working with students on these, and they were getting the long leg and the hypotenuse mixed up. So here we have the long leg, we have the hypotenuse, and of course we have the short leg. So from the long leg to the short leg, how do we go from there to there? We divide by root 3. So now we're going to have 6 over root 3. And this is where we have to rationalize this now. So we multiply by root 3 over root 3. And you end up with 6 root 3 over 3. But then guess what reduces? Haha! The 6 and the 3 reduce, and so that's left with just a 2 root 3. So there we go, right there. This is 2 root 3. That one was a little bit messier. Okay. Now to go from the short leg to the hypotenuse, not a big deal. We just times it by 2. So 2 root 3 times 2 is 4 root 3. You got it. So there we go. There's our 3 values. Totally. Yeah, I bet you if you're watching this right now, you're yawning. Nobody watches. All right, if we have the hypotenuse, we have 10 root 3, and that's the hypotenuse. How do I know it's the hypotenuse? Opposite of the 90, the longest side. Sometimes the pictures aren't that great. This is not that great of a picture. All right, so we have 30, opposite 30 is the short side, and then the other one, opposite of 60, is the long leg. So you have the long leg, short leg, and the hypotenuse. To go from the, you always want to go, listen, this is important. You always want to go from the hypotenuse to the short leg, or the long leg to the short leg. You never want to go from the hypotenuse to the long leg. It doesn't work. So to go from hypotenuse to short leg, we are going to divide by what? 2. So 10 root 3 divided by 2 is 5 root 3. Yes way. And then 5 root 3, to go from 5 root 3 to the long leg, we multiply by root 3. So 5 root 3 times root 3 is 5 times 3, which is 15. You divide if you're going from, the longer one to the shorter one. Sometimes they're rotated differently, so you got to pay attention to the values: long leg, short leg, hypotenuse. How is it 15? Because it's 5 root 3 times root 3. So you end up with 5 times the square root of 3 times the square root of 3, which is 5 times 3, right? Because root 3 times root 3 is just 3. All right. Then the last one here, this one's the best scenario when you're just given the short leg. So to go from the short leg to the hypotenuse, we double it, so that's 6. And to go from the short leg to the long leg, we multiply it by root 3, so that's just 3 root 3. So, that's kind of the most basic example, is when that's the scenario, when you're given the short leg. Given the short leg, times 2 for the hypotenuse, and times root 3 for the long leg. Ha-ha! All right, next page. Give some mixed examples. I'm going to let you guys crush this in 1 minute or less. On your marks, get set, go. Okay, we're back. Let's check in. I made some marks on here. Some of the pictures are not perfect. So in the first case, you start with 45, 45, 90, and you have a leg of 10. So the other leg is going to be the same value, 10. And the hypotenuse is going to be 10 root 2. Okay. The 30, 60, 90, we're given the hypotenuse, so you want to go to the short leg, and the short leg then is going to be half, which is 5. That's the easiest one to go to. So the short leg and the hypotenuse are half or double. And then once you get that, you take that times root 3 to get the long leg. Okay, and then this one is also 45, 45, 90. It's not drawn very well, but you got to go with the markings on the triangle. So then to go backwards from the hypotenuse to the leg, I'm going to divide by root 2. Okay, because it's smaller, so you end up dividing by. So then this is going to be 10 over root 2. And after you rationalize that, that's 10 root 2 over 2, which is 5 root 2. So each side is 5 root 2. So 5 root 2 there, and 5 root 2 here. The short leg is always half of the hypotenuse. See if I'm going to open up a blank page. So here we go. There's a 30, 60, 90, right? 30 degrees, opposite of the 30-degree angle is the short leg. Opposite of the 60-degree angle is the long leg. And opposite of the 90 is the hypotenuse. So whatever the short leg is, that's the easiest way to start. So if you start with the short leg right there, okay, and let's just say the short leg is 4. Okay, then what's the hypotenuse? 8, and the long leg? Oh yeah, I wrote 8. 4 root 3. Right? If you start with the hypotenuse, okay, and let's just say that's 12, now you got to work backwards because you have the longest side. So now to get the short leg, you have to divide it. So this is going to be 6, And you always want to get the short leg first. So you get 6 and then take it times root 3 to get the long leg, right? Okay. The most annoying scenario is when you're given the long leg. So if the long leg, let's say, is like, I don't know, 9, then to get the short leg, I have to divide that by root 3. So now I'm over here doing 9 divided by root 3, but then you got to do all that messing around with the radical. So that's 9 root 3, and then you rationalize it, and you get root 3 over root 3, and you multiply it, and then you get 9 root 3 over 3, and then you cancel out the 3 stuffs, and you end up with 3 root 3. So after you've done a bunch of those, you do kind of come up with some little shortcuts probably. So that's 3 root 3, and then to get the hypotenuse, you times 2 to get 6 root 3. So it's just uglier because they're not nice, neat, friendly numbers. You got to be able to work with the radicals. Okay. So this last one here, this is where we're start out. We're given 10. Can't see it because it's off the video for some reason. But oh, there we go. Yeah, this one over here is a little bit off too, unless I just moved the whole thing. Yeah, I did. All right, so the medium or the long leg is 10. So now to get the short leg, this is where I have to divide by root 3. So it gets to be a little annoying. So we have 10 divided by root 3, which is ultimately going to be 10 root 3 over 3. And then to get the hypotenuse, you times by 2. So you get 20 root 3 over 3. And that's the best you can do reducing wise. Yep. So whatever the last, last page is the combo problem. So you'll see maybe a whole bunch of stuff comboed up together. And in this case, we start with the given information of the hypotenuse of the 45. 45 is 12. So divide by root 2. I'm going to get, I'll use some scratch paper over here, 12 root 2, 12 over root 2, which is going to be 12 root 2 over 2, which is ultimately 6 root 2. So 6 root 2 for there and there. Okay, and then we jump into this 30, 60, 90 triangle, and it's actually easier to find E next. So I'm going to find E, the short leg, and to go from the long leg to the short leg, because see, look, this one's the hypotenuse because it's opposite the 90, right? This is the long leg, this is the short leg. So to go from long leg to short leg, I got to divide by root 3. So that's 12 divided by root 3, which is 12 root 3 over 3, which ends up being 4 root 3. So right here I have E is 4 root 3, and I found that before I found D. Now to go from short leg to hypotenuse, I times by 2, so this one now is going to be 8 root 3. That's how you get the D there. And then F is the same as E, that's also 4 root 3 because it's an isosceles triangle. And within the 45, 45, 90 triangle, to get the hypotenuse, I times by root 2. So this is 4 root 3 times root 2, which is 4 root 6. Okay. And then another thing I will say too is there's a question in the homework where it looks like there's a 30, 60, 90, but it doesn't have the values written in, and it's actually not a 30, 60, 90. And you'd have to use Pythagorean theorem to get one of the sides. So there's a little bit of some curveballs thrown in there. And then when it says exact values, so it says keep your values in exact values or something like that. That just means leave them as radicals. Because if you change a radical to a decimal, now you're starting to approximate it. Because like the square root of 12, is that a perfect square? No, so it's an irrational number. So it goes forever with no repeating pattern to it. So if you put it in a calculator and get a decimal, it's an approximation. So, all right, good job. Under 20 minutes. Oh!